Today we are going to solve some of the problems on previous year question papers. First problem, find the even and odd components of the signal x of t is equal to 1 plus e to the power 3 into cos to the power 10 into t. It is given x of t is equal to 1 plus t cube into cos to the power 10 into t. We know that x of minus t is equal to 1 plus minus t cube into cos to the power 10 into minus t, which is equal to 1 minus t cube into cos to the power 10 into t. Then x e of t is equal to half into x of t plus x of minus t, which is equal to half into x of t is 1 plus t cube into cos to the power 10 t plus x of minus t is 1 minus t cube into cos to the power 10 into t, which is equal to cos to the power 10 into t. Similarly, x naught of t or odd signal is equal to half into x of t minus x of minus t, which is equal to half into x of t is 1 plus t cube into cos to the power 10 into t minus x of minus t is 1 minus t cube into cos to the power 10 into t, which is equal to t cube into cos to the power 10 into t. This is the required answer for even and odd signals. Next problem, find the overall operator of a system whose output signal y of n is given by y of n is equal to 1 by 3 into x of n plus 1 plus x of n plus x of n minus 1. Also, draw the block diagram. So we can draw the block diagram S inverse x of n x of n minus 1 x of n plus 1. We have to put one summation and we have to add all the three, x of n minus 1, x of n and x of n plus 1. That will give, and that should be multiplied by 1 by 3. One by 3 into x of n plus 1, x of n minus 1 and x of n plus 1, which is equal to y of n. Therefore, transfer function of t is equal to 1 by 3 into S inverse plus 1 plus S. For the given signal, determine whether the system is linear time invariant, memory, causal and stable. It is given y of t is equal to x of t by 2. Y of t is equal to x of t by 2. Let y of t is equal to t of x of t, which is equal to x of t by 2. First, we will check linearity. T into a into x1 of t plus b into x2 of t is equal to a into x1 of t by 2 plus b into x2 of t by 2. Which is equal to a into t of x1 of t plus b into t of x2 of t. Therefore, the given system is linear. Second one, we have to check it is whether it is time invariant. T of x of t minus t naught is equal to x of t by 2 minus t naught. Y of t minus t naught is equal to x of t minus t naught by 2. Therefore, y of t minus t naught is not equal to t of x of t minus t naught. Therefore, the system is time variant. Next, we have to check it for memory. For some instant of time, the output y of t depends on past value of the input, that is y of 2. If I take, we will get x of 1. Therefore, the system is not memoryless, or it has some memory. Next, we have to check it for causality. Once again, at some instant of time, output y of t depends on future values of input x of t. That is, y of minus 4 is equal to x of minus 2. Hence, the system is non-causal. Next, we have to check it for stability. Let x of t less than or equal to dx less than infinity, bounded input, bounded output, then mod of y of t is equal to mod of x of t by 2 less than equal to bx less than infinity. That is, if input is bounded, then output is also bounded. Therefore, the system is stable system. Find the even and odd components. of the following signals. First one, x of t is equal to 1 plus t plus 3t square plus 5t cube plus 9t to the power 4. Then x of minus t is 1 minus t plus 3 into minus t whole square plus 5 into minus t whole cube plus 9 into minus t to the power 4, which is equal to 1 minus t plus 3t square minus 5t cube plus 9t to the power 4. Therefore, x e of t is equal to half into x of t plus x of minus t, which is equal to 1 plus 3t square plus 9t to the power 4. Similarly, x odd of t is equal to half into x of t plus x of minus t, which is equal to t plus 5 into t cube. Second one is x of t is equal to cos t plus sin t plus sin t into cos t. Then x of minus t is equal to cos of minus t plus sin of minus t plus sin of minus t into cos of minus t, which is equal to cos t minus sin t minus sin t into cos t. Therefore, x e of t is equal to half into x of t plus x of minus t, which is equal to cos t. Then x naught of t is equal to half into x of t minus x of minus t, which is equal to sin t plus sin t into cos t, which is equal to, if I take sin t outside, 1 plus cos t. What is the total energy of the rectangular pulse shown below? It is given pulse as x of t minus t by 2 plus t by 2. It's a, this is 0. We can write from the given figure x of t is equal to a, where mod t is less than equal to t by 2 and 0 otherwise. And the energy is given by summation integral minus infinity to infinity mod of x of t whole square into dt, which is equal to minus t by 2 plus t by 2 mod of a square into dt is equal to a square into t. Check whether the following signals are periodic or not. If periodic, find the fundamental period. First one, x1 of n is equal to cos 2 pi n. So comparing this equation with x of n is equal to cos ohm naught n plus pi, we will get ohm naught as 2 pi, which is equal to 1 divided by 2 into 2 pi. Therefore, m by n is equal to 1 by 2, which is a rational number. Therefore, it is periodic signal with fundamental period n is equal to 2. Next one, x2 of n is equal to cos 2n. So comparing this equation with x of n is equal to a cos ohm naught of n plus phi, then ohm naught is equal to 2, which is not equal to m by n into 2 pi. That means it is non-periodic signal. Next problem, for the continuous time signal x of t as shown below, sketch the signal y of t is equal to x of 3t plus 2. The given signal is it is -1 and it is 1. With amplitude 1, this is x of t. So according to precedence rule, first we have to obtain v of t, that is x of t plus 3, representing the time shifted version of x of t. Then we have to compress it by factor of 3 to get y of t is equal to v of 3t, which is equal to x of 3t plus 2. So first we have to draw v of t is equal to x of t plus 2. This is t 0. That means we have to shift the given signal by 2 units in the left hand side. X of t plus 2. This is 1. This is positive 1. This is negative 1. Negative 2. Negative 3. So it is like this. Now we have to draw y of t is equal to v of 3t, which is equal to x of 3t plus 2. We have to compress the previous figure. This is t, this is y of t with amplitude 1, this is 0, this is minus 1 by 3, this is minus 2 by 3, this is minus 1. This is the required answer for the given problem. Sketch the signal x of t is equal to minus u of t plus 3 plus 2 into u of t plus 1 minus 2 into u of t minus 1 plus u of t minus 3. So first we will draw x1 of t as minus u of t plus 3. This is t 0, 1, 2, 3, minus 1, minus 2, minus 3, with negative value minus 1, and so on. Next, we have to draw x2 of t as 2 into u of t plus 1. This is t, 0, minus 1, minus 2, minus 3. This is 1, 2, and 3. So it starts from minus 1 with amplitude 2. Next, we have to draw x3 of t minus 2 into u of t minus 1. This is 0, minus 1, minus 2, 1, 2, 3. T minus 1 given, that means it is started from plus 1 with amplitude minus 2. And next is x4 of t is equal to u of t minus 3. T 0, 1, 2, 3, minus 1, minus 2, minus 3. T plus t minus 3, that means it will start from plus 3. The last one x of t, combining all the signals, we get the output as 2, 3, minus 1, minus 2, minus 3. So minus 3 to minus 1, the amplitude will be minus 1. Then minus 1 to plus 1, amplitude will be 1. Once again, 1 to 3, amplitude will be minus 1.